quite a while ago, I'd say like probably January or February, I picked up this 1952 Sunbeam T-20b automatic toaster for about $5. Now unfortunately it was covered in paint, and I used steel wool to get the paint off. I know I did hurt the chrome a little bit, but some of the brush strokes were going the opposite way of what I was brushing, so I'm thinking they might have brushed it before they painted it. Well, either way, I'm going to be making a vacuum deposition chamber so I can put aluminium on it to make it nice and shiny again. So it's not a big deal. It actually opens up a possibility of a future project. But unfortunately, the coils were kind of bad. They're kind of bent in there. And the main mechanism, oh, it's on this side. The main mechanism has some issues with the bi-metallic strip, I think. Well, anyway, so I haven't really been using this, but then I found this one at the Jacksonville Steam Engine Festival. Got it for $5 also. And I have to say, it's in pretty much mint condition. It's plugged in. Now it has a newer cord, someone replaced it. And unfortunately on the bottom it does not have a date code. Oh well. This is how the toaster should work. Well, look at that. Perfect. That's pretty well done. I said let's let this cool off, and then we'll open it up to see how it works. Actually, you know what? Before we take it apart, let's check the resistance of the coils. Now, of course, right now it's not switched on, so we'll use my screwdriver to push the thing down. Now that the relay is connected, it has 11 or so ohms of resistance. Now, I'd say anything between 10 and 12 ohms is good. So if your toaster has around 10 or 12 ohms, then your electrical system is probably perfectly fine. If it's any different than that, though, you might have like a broken wire or something in there. Who knows? But yeah, that's a good number to know if you're fixing up a T20b. Here's the bottom of it. Now on my other toaster I had, there was a date stamp like down here, or maybe it was up here, I can't remember, but it said the exact day that it was made. This one doesn't have that, unfortunately. It'd be nice to know when this was made, though. Now, in order to take off this base, we have to take off this knob. And also keep in mind that this knob can only move this far. So sometimes problems can be fixed by removing this and recalibrating it, because then you can turn this many times, whereas this only goes that far. Slide this down the power cord. So now we have 8 little bolts holding the chrome pieces on. Take off these 2 and these 2 first to take off the outer main shell. Actually, I found that most of these like multi-bit screwdrivers fit this perfectly. Watch out though, because this piece of metal is pretty hard to stretch back over this. See, it's almost like spring-loaded, so it's a pain to get it to align upright whenever you put it back together. But oh well. We flip it over. Pull this off. Now I have this piece undone, and you could probably take time to clean this if you want. Now there's really not much interesting underneath the plate on the power side, so I'm not going to worry about undoing that one. All the stuff is on the other side. So that's just 2 more bolts. Now, if the toast holders on the toaster are ever like really low and they just don't want to come up, or if they're like just really almost stuck to the top and really hard to push down, you adjust the bottom spring. Of course, these were tuned okay. I just untuned it for demonstration. See, I'm tightening the spring mechanism. So now these are nice and tight. How this works is, okay, so you put your bread in. So the bread is in, and it pushes this little arm down. Now this arm comes around, and it hits this piece right here. Now that comes down and pushes this relay contactor in. So when the contactor makes a connection, it allows the current to pass through the coils. That makes the thing heat up. Well, as it heats up, the inner part retracts. I haven't actually taken it apart that far to see how it does that, but as it heats up, it pulls this part up. And by pulling this part up, it pulls these down by the mechanism back here. It's a pretty stiff mechanism. So then this falls down. Now, inside of here, inside of this little block right here, is a bi-metallic strip. On the inside, when enough infrared radiation hits it, it heats up and it pops out. And that breaks the connection. And now the stuff comes up. The only difference is this little switch comes up underneath this little piece right here. And how this works is whenever you remove the bread, it resets it. So when you put it in, pushes it in again. So this is acting like one bit of memory. It's always kind of interesting because this is basically like a tiny computer. It only computes one thing. If bread, then go down. If no bread, come up or whatever. Probably just like one line of code, but still one line of code shown, or actually probably more like 2 lines of code shown in a really complex piece of machinery. Let's plug it in and see how it works in action. Works pretty well. It's a quite ingenious machine. Well, now that I've turned it on, I gotta wait another like 15 minutes for it to cool down for me to put it back together. Now remember, whenever you're putting this on there, it says one slice on one side of the chrome piece, and that goes on the side that has the little arm. Because if you want to cook one piece, you have to put it in this one. If you want to put 2, you put it in these. But you can't put one in here because then it wouldn't touch the sensor bar and it wouldn't turn it on. Whoops. Well, there went my screwdriver. Now that that's done, we can just finish this, which I gotta say is the easiest step of putting this thing back together. And lastly, add the knob. It's always such an ordeal to get these things back together. Oh well. But that's how you open them up, and that's how they should work. pretty good doneness for me. Perfect. Hope you guys enjoyed this video, and thanks for watching. See ya!